Okay, today I'm going to discuss loop. So I will insert a module and let's name it as mod loop example. So as usual, so I'll add option explicit on the top and let me decrease the font size. Loop is used to perform repetitive tasks. A loop has three parts. So this is an example of for loop, and for loop has three parts. So the start, the end, and the increment or decrement. So let me execute this and show it to what will be the output. So you'll get an output from 1 to 10. If I press F8 and execute it, so first of all I will be initialized. So this is how loop works actually. So you have to understand it. So I will become 1 after the execution of this line. So I is now 0 after I execute it. Now I is 1. Debug.print I will print I on the immediate window. Then next I. So after the execution of this line I will become 2. So I will increase by 1 because you have provided step 1. So I will become 2. Now debug.print I 2 will be printed. So like this it will go on. So when it becomes 10, now see I 10 has already printed. Now I is 10. So if I press F8 I will become 11, and since 11 does not fall within this range, the loop will terminate. So this is how loop works. It's very simple. Okay, hello viewers. Let me try to explain you the concept of loops in a different way. So let's assume that you are the programmer and I am the computer. So you are writing certain instruction which I should follow. I as a computer should follow. So loops are used to do repetitive tasks. That means you want me to repeat certain tasks. So you are writing the code in this way. Okay. So you have written this code. Count from 1 to 10. You want me to count from 1 to 10. I am the computer. And in every count, you want me to do certain tasks. So let's say the first task you want me to do is jump. And let's say drink water. I am the computer. So how will I follow the instructions? You have written this instruction. You have marked it as start and end. And these are the two tasks I should do. So I should count 1 and then jump and drink water. So this is how I will do it. I will count 1, I will jump, I will drink water, 2, jump, drink water, 3, jump, drink water. So I will repeat this up to 10. So this is how you write a program in loops. So this is not exactly how we write a program, but I try to explain you the concept of loops. So the computer needs a counter. So you have to give him a counter to count, and in every count you will perform certain operations in a sequential order from top to bottom, and you have to mark the start and end of it. So now let's see in real world how you can write a loop. Okay, so I have written this program in VBA language. So how will it work? So remember, count from 1 to 10. So now it becomes for I equals to 1 to 10 step 1. And then there was a start and end. So the end is marked by next I. So between these, whatever instructions are there, it will be performed sequentially one by one. Debug.print, so computer cannot jump and drink water. So I have put a debug.print which will display the output in the immediate window. Debug.print jump, debug.print drink water. Next I. So how will it run? So it has to be, there has to be a counter. So counter variable with which the computer will count. So I have provided I for I equals to 1 to 10 and dim I as integer. So it will count 1. So I will become 1 in the memory, and then it will display this output jump, drink water, and then when it comes to next I will be incremented by this step 1. So I will become 2. Then again this will be printed in the immediate window. So like this it will continue. It will continue to print jump, drink water, jump, drink water, jump, drink water 10 times. And then I will become, finally I will become 11. And 11 will not be a part of this range 1 to 10. And the loop will exit. So basically you can also write step 2. So how, if you write step 2 for I equals to 1 to 10, step 2, it will count 1, 3, 5 like that. You can also do a reverse way, 10 to 1, step minus 1, then the counter will, then the value of I will decrement every time. So this is how you have to tell the computer to do a repetitive task in VBA. You can do the same using a while loop also. So if you use a do while loop or a while loop, then the syntax will be a little bit different, which we will see during the programming. But essentially, like loops are used to do repetitive tasks. So there has to be a counter variable, like for in this case I is the counter variable which increases, and then it goes out of the limit, which is the terminating condition, and the loop terminates. So the concept will be same with for loop, while loop, and other types of loop. If I take another example, step 2. This time I will increment by 2. Now if I press F8, I is 1, debug.print I 1. Next I will increase I by 2. So I plus 2, 1 plus 2 is 3. So similarly it will print up to 9 and terminates. So when I becomes 9, so 9 plus 2 becomes 11. So 11 does not fall within this range. Hence it terminates. So basically you can say that this is the output for all the odd numbers from 1 to 10. So what if I want to display all the even numbers from 1 to 10? So I can start from 2 to 10, step 2, it will display all the even numbers. Okay, so I have to change the name. 2, 4, 6, 8, 10. Now what if I want to display the sum of first 10 natural numbers? So I will declare one more variable and I will call it sum as integer for I equals to 1 to 10, step 1. Sum equals to sum plus I. Debug.print sum. If I execute it step by step, F8, okay, again I have to change the name. I is 1. So sum is right now 0. After the execution of this line, 0 plus 1, now sum will become 1. So next I increases by 1, so I becomes 2. Now sum equals to sum plus I. Sum was 1, 1 plus 2, now sum becomes 3. Now I becomes 2 plus 1, 3. Now sum becomes 3, sum is 3 now. 3 plus I is 3, sum becomes 6. Now I becomes 3 plus 1, 4. Now sum is 6, 6 plus 4, it will be 10. Sum becomes now 10. So like this it goes on, and if I press F5, it will print 55. So 55 is nothing but 55 is 1 plus 2 plus 3 up to 10. Similarly, you can write sum of all odd numbers from 1 to 10, sum of all odd numbers. So I just have to do step 2. So 1 plus 3 plus 5, like that. Again, I have to change the name. 25. Okay, now I want to display the sum of square of first 10 natural numbers. So let me make it example 6. So I'll make it step 1. Now I want 1 square plus 2 square plus 3 square, so like this up to 10. So what I need to do, I simply need to do I into I. If I run this, it will give me 385. Now there is another way of writing this for loop. So in fact you can instead of ascending order, you can also follow a descending order. So if I write for I equals to 10 to 1 step minus 1, and let me remove sum and debug.print I. See, it prints from 10 to 1. What if I write here for I equals to 10 to 1 step 1? The condition is invalid. So 10 to 1, but you are doing a step 1. So it will not enter inside this for loop. So it will go outside. So this is the body of for. So there can be multiple lines. And that is the reason actually why you put a tab actually. So you can understand. So whatever line you write, so all of this becomes part of the for loop. So once for every iteration, like every cycle is called an iteration. For every iteration, this all the lines inside the for loop will be executed. Let's say debug.print I. If I write him sum as integer, sum equals to sum plus I, and debug.print sum. So it will do two things. First of all, let me execute it step by step. I is initially 0. After the execution of this line, I will become 10. Okay, sorry, this will be step minus 1. I is 10. Debug.print I 10. Sum equals to 0. Sum is initially 0 because this is a number. If you do not assign anything, the default value is 0. So 0 plus 10 is 10. Next I. So I will now decrement by 1. I was earlier 10. Now I will become 9. Debug.print I will print 9. Sum is like 10. 10 plus 9, 19. So this way actually it will go on, and at the end it will print the sum of 10 plus 9 plus 8 up to 1. So it will print 55 at the end. Debug.print sum. Now I want to display all the prime numbers from 1 to 50. Step 1. Actually prime number starts from 2, so we can make it 2. Let me remove this, Control Y. So what is the logic for this? So what is a prime number? Any number which is not divisible by 2, 3, 5, 7 and 11. So these are prime number, like any number which is not divisible by 2, 3, 5, 7 and 11 is a prime number. Plus prime number also includes 2, 3, 5, 7 and 11. So what about 12? 12 is divisible by 2, 12 is not a prime number, 13 is a prime number, 17 is a prime number. So like this, like that it goes on.
19 also is prime number.
Yeah, so it will go on like that. Yeah. So how to display the prime numbers between 2 and 50? So there is a operator called mod. So if I write let's say 5 mod 2, the output is 1. If I write 7 mod 3, the output is 1. If I write 8 mod 3, the output is 2. So using a question mark, you can evaluate any kind of expression in the immediate window. So you can write like 12 plus 10, you can write 12 plus 10, it will give you 22. So can anybody guess what mod means actually, what it is doing? Let's say 13 mod 5, the output will be 3. Can anybody guess what mod does?
It is the division.
13 by 5 is how you can with 3. 13 by 5 is not 3.
There is the remainder is the 3.
Absolutely. So you are correct. So mod gives you the remainder. So we will use this mod operator. So mod is an operator like plus, minus, multiply, divide, mod. Mod is also an operator in VB. It is considered an operator. So we will use this mod. So if I mod 2 is not equals to 0, so there will be a remainder. So any number which is not divisible by 2, if a number is not divisible by any number, so we get a remainder, right? So if it is not equals to 0, so or let's say greater than 0, you can also write this. You can see here like is 7 a prime number?
Yes, it is.
Yeah, 7, 11, 13.
Yes.
13 is a prime number. 13 mod 2. So if we write 13 mod 2, what is the remainder? 1.
1.
Yeah, so 1 is greater than 0, right? 1 is greater than 0. So we have written this condition. If I mod, so if is a statement. So try to understand it in simple English. So if I divided by 2 and there is a remainder, so it is not 0, not equals to 0. If I write 12 mod 2, it is 0. So is 12 a prime number? 12 is not a prime number. So for any number to be prime, there has to be a remainder. So it has to be, the remainder has to be greater than 0, right? So this is the condition. I mod 2 greater than 0 and I mod 3 greater than 0 and I mod 5 greater than 0. Similarly, I mod 7 greater than 0 and I mod 11 greater than 0. Then again you have to close this, and if so, if closes here, you have to print debug dot print high. Now let me execute it step by step. F8. Initially, so I is 0. So after the execution of this line, I will be 2 because it starts from 2. Is 2 mod 2 greater than 0? We will try here. 2 mod 2 is 0, not greater than 0. So this is false. So this will not go inside if. So if I press F8, so it will go here. So it will skip whatever is inside the if. So this has got nothing to do with the indentation, the tab. Even if you don't give the tab, still it will work in the same way. So I'm dragging this up. I'm dragging this pointer up. So even if you don't give the tab is just for visibility, better visibility and understanding, readability. So it is clear that this is a part of if. So it will skip. Now next I will become 3. So now it will check 3 mod 2 greater than 0. So if let me put this entire condition, 3 mod 2 greater than 0, false, true. 3 mod 2 greater than 0, yeah. So 3 mod 2 is greater than 0. There is a remainder. So 3 is not divisible by 2 and you get a remainder. But is 3 mod 3 greater than 0? Now it will check this. False. So it will not enter inside this actually. So it will skip this like this. Now I becomes 3 plus 1, I becomes 4. Like this it will continue to check. It will continue to check. I becomes 10. It will continue to check. Now it entered. Why it entered? We have to see now why it entered. What is the value of I? I is now 13. Now all of these conditions are false. I mod 2 greater than 0. If I write it is all of these conditions are true. So if all of these conditions are true, this is true and this is true and this is true and this is true and this is true, then only it will enter the if. So in other words, it means if I is not divisible by 2 and I is not divisible by 3 and I is not divisible by 5 and I is not divisible by 7 and I is not divisible by 11, then execute whatever is inside this if. Now it will enter in the if body actually. It will print 13. So similarly it will again go on, and again I think now it is 17, so it will print 17. So like this it will print all the prime numbers. But there is a problem. So 2, 3, 5, 7 and 11, these are also prime numbers. So what you can do is you can simply print debug.print 2, debug.print 3, 5, 7 and 11, and you can start this loop from, you can start checking from 12. So now what will happen, it will print 2, 3, 5, 7, 11. Now start checking from 2. Now it will continue checking from 2, it will print 13, and this way it will print all the prime numbers from like 1 to 50. There is another way of doing it. So let me copy this. Instead of writing so many print statement, what you can do is you can start checking from 2 to 50. You don't need this. All you need is you can put an or. Or I equals to 11. Now if I execute this, okay, I is 2, it is entering because these conditions are false actually. If I simply copy this and take it to the immediate window and print this I mod 2 I mod, so current value of I is 2, so in the immediate window it will consider 2, so 2 divided by 2, so this will be false actually. So because 2 divided by 2 is equal to 0, not greater than 0, right? So in the very first case itself it will be false, but now it will check there is an or. If this or I equals to 2, so now this condition will be true, so it will print 2. Similarly again for 3, the first condition will be false, but we have mentioned here or I equals to 3, so it will print 3. So like that it will continue to print all the sorry, let me delete this first, let me execute. It will print all the prime numbers from 1 to 50. You can do one more thing. So you can break this into 2 lines. For breaking it into 2 lines, you have to put underscore and then press enter. And you have to be careful that there is a space before this underscore. So this is a single line broken into two lines for readability actually. You cannot simply break it into 2 lines, it will give an error. So because like in day 1 I taught you like how do you end a statement, by putting a full stop. By putting a full stop you end a statement in English language, but in VBA you end a statement by terminating that line. But actually if so these will be considered 2 statements, but these are not 2 statements, this is a single statement. So you have to tell the compiler this is not 2 statement, this is a single statement, so you have to put an underscore here. If this is completed, we can also do it this way. And then debug.print I, we can write else if I equals to 2, then debug.print I or debug.print 2, whatever you want to write. You can. So this is a way of writing if else if, else if, and finally end if. So this will also generate the same output. So it will first check. So this will be false. So it is false. Now it will come here. 2 equals to 2. Yes, 2 is 2. Now debug.print 2. Now it will go here. So 2 is not equals to 3. So none of these will be executed. So it will print 2. Now I becomes 3. This will be false anyhow. Is 3 equals to 2? No. 3 equals to 3? Yes. Print 3. Like this it will go on, and it will print all the prime numbers from 1 to 50. Okay, now I am going to introduce you to another loop which is called do while loop. So this will print all the natural numbers from 1 to 10. Now I want to do the same thing using a while loop or a do while loop. Do while I less than equals to 10. Debug.print I. Now you have to write another line, I equals to I plus 1. The increment you have to do manually, and this will be loop. So this is the syntax for do while. Do while, and then there will be a loop. Now if I execute this, I is 0, 0 less than equals to 10. Yes, so it will enter inside the do loop. Debug.print I is 0, 1, 2, so it will go up to, now I is 10. Now it will ask, is 10 less than equals to 10? Yes, it will print 10. Now I will become 11. Now it will check, is 11 less than 10, less than equals to 10? No. Then it will terminate the loop. It will go outside the body of the loop. So it will go to the line which follows. So it starts from 0. So what if we want to make it start from 1? So what you have to do is dim I equals to 1. You have to just give I equals to 1. Now it will start from 1. Now 1 to 10. Same output. Now you can do the same thing using a while-wend loop. So this is another loop. So instead of do while, so the syntax is while and WEND. Everything else is same. So if I execute it, you get the same output 1 to 10. So I would not recommend you to use this while-wend loop. So it has a disadvantage. So I am just showing it for the sake of completeness of the training, and so that you know what is a while-wend loop. And there is something called do until loop. So do until is like by the word itself, until or till. So the synonym for until is till. Do till I equals to 10. So you have to reverse it now. Okay, make it 13. So if I write do till I equals to 1, so in the very first condition itself, so it is till I equals to 1. So till I equals to 1 means, yeah, I is 1 now. Okay, fine, now exit the loop. So until, so by English you can understand the meaning of this actually. So, and again it will display the same output 1 to 9. So you can make it do until I is 11, then it will display 1 to 10, or you can make it do until I greater than equals to 10. No, if I write I equals to greater than equals to, then again it will print up to 9, I guess. Yeah, because until I is either greater than or equals to 10. So if I equals to 10, so it will not enter. So you have to make it I equals to 11. And now it will print 1 to 10. So again, you should never use the do until loop. Based upon my experience, I can say. So the only loop that I recommend is do while loop. So there is another advantage of do while loop over the while-when loop. So you can prematurely terminate a do-while loop using the statement called exit do. So see what happens. Let me clear this. F8. Now it goes exit do, so it will go outside the do. So you can put this exit do inside a if condition to make it like suitable. You can put it inside a if condition, and you can prematurely terminate a do while loop. But you cannot do that with a while when loop. There is nothing called exit while. You cannot do that actually. So that is the advantage of do while loop. And there is another way of writing do while loop. You can put the condition here, do loop while. So now the loop will be executed at least once. So even if I is 100, irrespective of what is the value of I, the I is 100 is less than equals to 10, no, still it will print at least once. Now I becomes 101, and it will check 101 less than 10, no, and it will exit. So this is an advantage of do while loop, and hence I recommend using do while loop. And we try not to use while when loop. You will never have to write do until loop also. So these two loops are very important, the for loop and the do while loop. So if you like this video, please subscribe to the channel and hit the like button. Thanks for watching.